Good morning, children. This is Javeria taking physical science for class 9th. We are into the third session of Unit 9, What is Inside Atom. In our previous sessions, we had seen Thomson's model of an atom, Rutherford's alpha ray scattering experiment, and Niels Bohr model. Today, we'll be seeing how are the electrons distributed in different shells or orbits. According to the atomic models, electrons revolve around the nucleus of an atom in different orbits or shells. Electrons in different shells have different energies, and each shell is represented by a number small n, which is known as shell number or energy level. If the value of n is 1, then the shell is designated as K shell, and if the value is 2, it is designated as L shell, 3 M shell, and 4 N shell. So the maximum number of electrons is given by the formula 2n square, where n is the shell number. So in the first shell, it can accommodate 2 electrons, that is 2 into 1 square, that is 2. In the second shell, when L is the shell, then the number of maximum electrons it can accommodate is 8. 2n square, which is 2 into 2 square, which is equal to 8. Similarly, M shell, which is the third shell, it can accommodate a maximum of 18 electrons. So 2n square, 2 into 3, and here is 3, so 2 into 9 is 18. Coming to the fourth shell, that is N shell, it can accommodate maximum of 32 electrons. So 2 into 4 square, 4 is your shell number, that is N. So 2 into 16 is equal to 32. Therefore, the number of electrons which can be accommodated in each shell is given by the formula 2n square. Now coming to the arrangement of electrons for the first 18 elements. We all know that the first element is hydrogen. Its atomic number is 1. You can see hydrogen over here. Atomic number is given on the top right corner and symbol is given on the left top corner. Okay, children. And the central point, this particular thing, is the nucleus. And this is your first shell, which has got 1 electron in it. Okay. Then when coming to helium, the symbol of helium is He. Its atomic number is 2. So inside we have got the nucleus, and there are 2 electrons in the first orbit, that is your K shell or K orbit. So the capacity of K shell is 2 electrons, that is why we have got 2 electrons. Now coming to your third element, that is lithium. Its symbol is Li and its atomic number is 3. So inside you have got nucleus, 2 electrons are there in the first shell, that is K shell. After K we have got L shell. So one more electron is remaining. 2 are already there in the first shell, so 1 is remaining. So that particular electron goes into the second shell. Similarly for beryllium, the symbol is Be and its atomic number is 4. Inside you have got the nucleus. In the first shell you have got 2 electrons which are represented by black dots, and in the second shell we have got 2 more electrons. That is, since atomic number of beryllium is 4, 2 are inside and the remaining 2 are in the outermost shell. And here children, we are representing the outermost electrons by red color, which shows that they are the valence electrons, and the other inner electrons are shown by black color. Now the next element is boron. The symbol of boron is B and atomic number is 5. So you have got inside nucleus, then 2 electrons in the first shell and the remaining 3 in the second shell. Similarly for carbon, 2 electrons in the first shell, that is L shell, and 2 electrons in the K shell and remaining 4 electrons in the L shell. Nitrogen, 2 electrons in the inner shell, that is K shell, and remaining 5 in the next shell, that is L shell. Okay children, similarly coming to neon, right? So oxygen and fluorine also electrons are arranged in the same way. Now just come to neon. Neon has 10 electrons. So 2 are in the inner shell, that is K shell, 2 maximum capacity, and the next shell, which is L shell, its capacity is 8. So you see here 8 electrons in the outermost shell. Now coming to sodium, which has got 11 electrons. So here we have got in the inner part is your nucleus, and first shell, that is K shell, has 2 electrons. L shell has 8 electrons. So 2 plus 8 is 10. Now the 11th electron goes into the next shell because the capacity of the second shell is only 8 electrons. Here how we had seen the capacity of first shell is 2. So here only 1 is there, and here in helium you have got 2. Now when we came to lithium, it has got 3 electrons, but the capacity of the inner shell, that is K shell, is only 2. Therefore the next electron, that is the third electron, goes into the second orbit, that is L shell. Similarly for sodium, first shell has 2 electrons, second shell maximum capacity is 8, so 2 plus 8, that is 10 electrons, and the next electron, that is the 11th electron, goes into the next shell, which is your M shell. Okay children, similarly till we come to argon, the atomic number is 18. So inner shell, that is your first shell, that is K shell, can accommodate 2. Next shell is L shell, which can accommodate 8 electrons, and the next 2 plus 8 is 10. Remaining 10 electrons goes into the third orbit. Okay children, whereas the capacity of third orbit is around 18 electrons. It can accommodate 18 electrons. Okay, but for argon we have got only 18 electrons, so 2 in the first shell, that is K shell, 8 in the second shell, which is L shell, and again the remaining 8 in the third shell, which is M shell. Now coming to valency, the valency of electrons present in the outermost orbit of an atom is called its valency, and the valency of an atom explains the combining capacity of the element with other element. Now here if you see, this is the atomic model of a hydrogen atom. This is your nucleus, and we have got 1 electron in the first shell. So this is only the outermost shell for hydrogen, and since there is only 1 electron, the valency of hydrogen is 1. Now coming to carbon, in the inner shell, that is K shell, you have got 2 electrons, and in the outer shell, that is outermost orbit, we have got 4 electrons. Therefore the valency of carbon is 4. Now coming to oxygen, inner shell, that is K shell, has 2 electrons, and the second shell, which is L shell, has 6 electrons. But here the valency of oxygen will not be 6 because it is difficult to get rid of these 6 electrons rather than taking 2 electrons. Therefore, the valency of oxygen here in this case will be 8, that is octet. Number of electrons, if it is 8, it is known as octet. So 8 minus number of electrons in the outermost shell. Number of electrons in the outermost shell here is 6. So 8 minus 6 will be getting the valency of oxygen as 2. Okay children, that is why if there are more than 4 electrons in the outermost shell, we take valency as 8 minus number of electrons in the outermost shell. Otherwise, if you have 4 or less than 4, the number of electrons in the outermost shell will be its valency. Now coming to sodium, atomic number is 11. So 2 in the first shell, 8 in the second shell. So in all 10 electrons finished, and the 11th electron goes into the third shell. So you have got only 1 electron in the outermost shell. Since there is only 1 electron in the outermost shell, and it is known as your valence electron, and valency of sodium is 1. Now if we come to the noble gases, okay children, we have got noble gases: helium, neon, argon, krypton, xenon, and radon. All these noble gases in the outermost shell, they are completely filled, that is they have either 2 electrons or 8 electrons, and helium is the only noble gas which has got only 2 electrons. Other than helium, neon, argon, krypton, xenon, radon have 8 electrons in their outermost shell. Coming to the assignment, first question, define valency. Second, how many electrons can be accommodated in K and N shell? Third question, what is the valency of zero group elements? Fourth question, what is the symbol of hydrogen, magnesium and chlorine? Thank you.